one of those puzzles where you're looking for something different in two pictures.
There's 7 differences.
Yeah. It's just like that, except there's only one difference that I.
It's like that where that meets where's Waldo.
Yeah. Very. This is actually this whole semester has been huge for. Are we seeing any inconsistencies here?
Why are they saying only 4 to 5% goes to
Goes to what?
goes to the heart? Right, that's the heart.
It's gonna be the same amount of blood, depending on the flow.
Well, in this case,
Why are they
it's talking
listing it
about
twice?
flow to the organ. So how much of the cardiac output is just dedicated to perfusing that organ. So in this situation, we're talking about coronary artery. And 4 to 5% of 25 is
This is just systemic circulation. This doesn't come with a lung.
yeah, I guess the lungs are on it. That's a good point.
So there's 2 then.
Yeah, looks like there's maybe 2.
Well, lungs have an automatic diffusion
Does
system.
it help if they calculated these percents?
They're not exactly being,
Yeah, like it has like 3% are missing.
that's not an exchange.
Yeah.
Just much what I said.
The brain should have the same amount of blood flow. And I think the kidney should have less during exercise.
Okay. Anna, you got anything to contribute? Wendy? So, I like where everybody's giving some pretty good points here. In terms of brain blood flow, absolute amount of blood that goes to the brain stays pretty constant. You gotta look, it's 3 to 4% of 25 liters, whereas, you know, at rest it's 15%, but it's 5 liters. So it stays fairly constant. Now, if you do some sort of like exercise with like a mental task, you'll have bigger increases in blood flow. So this is the one that I was really thinking at if my laser works. That one, 4 to 5%, and then apparently there's just no blood flow going to your skin during exercise. Right? Isn't that crazy? We're talking about pretty intense exercise, and you guys are learning about cardiovascular drift.
Well, your skin dies.
Outside of muscle, biggest blood suck, if you will, is the skin.
Are they
And so-
including that?
I wonder if they meant 80 to 85% being over the skin and.
Yeah, that's because it's kind of in the middle.
They could say that, yeah, that's tricky. But yeah, so the 2 biggest organs in your body in terms of taking up blood flow is your entire muscular system and your skin. So if they're doing this exercise in a hot environment, these 2 things are going to be closer to 50-50 than anything else. But if you're in neutral environments, you're still going to have quite a bit of blood flow at the skin, and also tons and tons and tons during to muscle.
So that's like the number 3 reason for blood in the first place is heat distribution.
Right, and that's the whole point of cardiovascular drift that you guys are kind of reading is these 2 things sometimes have to compete. And that's tough because it'll either affect performance or it'll affect your body temperature. Body temperature will kill you, performance you'll probably just slow down, but your body has to make that decision for you, and it's tough. So, otherwise, I think it's pretty good. It gets the point across at least. Okay, look at how much blood flow of 5 liters is going there, but now at heavy exercise, there's hardly any going to the gut, essentially. Okay, so that's pretty cool. Yeah. Okay, and so intrinsic control of blood flow is the more correct way of saying functional sympatholysis. Okay, it's going to alter the just intrinsic or local blood flow to an organ, and it's done just simply through overriding signals, which is the metabolic portion. Endothelial, that's more of like flow-mediated dilation. basically the endothelial cells that line your vessels, they can secrete nitric oxide and other things that cause vasodilation, and they'll do that whenever they see that there's a huge, amount of shear stress on the circulation.
Is that
Okay.
more a pH controlled thing with nitric oxide?
No, it's really a function of how much stress is on the vessel wall.
So actual stretch and such.
Yeah,
Got
yeah,
it.
yeah. And so the last one's myogenic, and certain areas are really, really good with myogenic control. And all that means is when they sense that pressure goes high, so if we rearranged, let's see, to here. So in certain cases, if pressure goes up and it wants to maintain a normal amount of blood flow, they will increase resistance automatically. This is called autoregulation or myogenic control. Can you think of a part of your body that may want to keep blood flow very, very, very constant? Brain. Your brain primarily does that. Okay, there are other organs. I think the kidney has a little bit of this, and your heart has a little bit of this as well. Okay, so these are the three terms, but this one is why you get a redistribution during exercise. These two are more of kind of a maintenance control. Okay, and this is just breaking it down. And so, again, for endothelial cells, they will actually secrete a number of different things that act on the smooth muscle and cause you to vasodilate. Okay, it does respond to chemicals as well. And then this one is done by local pressure changes, just to try to keep flow constant. So this one's goal is to keep flow constant. These can allow for more flow. Okay, and all of these are intrinsic controls for blood flow, meaning that they will control blood flow in a very small region. Right, and here is more of a visual of it. So, metabolic is the top, and this is the functional sympatholysis we're talking about, when muscles produce all these things, or if you have an increase in temperature because you're exercising, things like that. You'll secrete all those things, and that will cause vasodilation. It will override the signal. Okay? Myogenic is when it just responds to pressure in this way. Okay? So if there's all of a sudden an increase in pressure sensed, it will increase resistance to keep flow constant. Okay? And this one is endothelial mediated, so when it sees that there's this big increase in flow through the area, the endothelial cells will secrete a little stuff, it will vasodilate, and you will get more flow to that area. So these are our three intrinsic controls of blood flow. Intrinsic. Extrinsic is when we start talking about these. Okay? Extrinsic means not nearby, not local. This is a global signal. So extrinsic would be your autonomic nervous system and hormonal control. Okay? This signal is sent everywhere and multiple tissues will respond to it rather than just a local influence. Okay, and this is something that's not tricky, but it will trip people up. So at rest, everybody right now has a certain amount of vasoconstriction that's going on. Okay, that's your vessel tone is what it's called. Okay, so you have a certain amount of constrictor tone in all of your vessels right now. It's not the most, but it's not the least. And what you can do is you can increase the amount of sympathetic nerve activity and cause more constriction, or you can just pull back the amount of sympathetic nerve activity, and that can be called dilation. You don't actually have the ability to vasodilate by sending parasympathetic nerve activity to blood vessels other than your genitals and your gut. Okay, so the vessel diameter is really controlled by exclusively manipulating sympathetic nerve activity, unless you're talking about your genitals where you go. That's why when you watch golf, there's a lot of Viagra commercials, right? If you don't watch golf, you should just. They're sponsored by every pill imaginable. They always will claim it could cause an unsafe drop in blood pressure. And it's because it basically hyperactivates your ability to vasodilate in regions that you're normally not vasodilating in for these individuals. So it can sometimes cause an unsafe drop in blood pressure.
Should we just lay down?
Yeah, they just get a boner and lay down. That's it. Yeah, that's it. That's how Viagra works, guys. That should be on the pamphlet, like as a precaution.
Just lay down?
You start to feel a little lightheaded, but you got what you need. Fall down. Okay, so that's extrinsic control. It's all done through sympathetic activity or humoral or hormonal control. And so this is exactly what we just talked about, except autoregulation is its kind of own thing. And this is autoregulation, meaning it automatically will regulate itself. And this is primarily a myogenic thing. Okay, and it's any tissue bed or any organ that wants to keep blood flow very, very constant is going to autoregulate. It's going to override the signal, just like when you're exercising, you'll get an overriding of the sympathetic constrictor tone. And your brain is very, very sensitive to CO2. Okay. A few more slides and then we're done. By the way, Dr. Davis didn't tell me what to lecture until about 8 o'clock last night. So, just so you know, it's not just you guys that he keeps in the dark. It's also me. So you'll have a circulatory response that's always going to be in proportion to the activity that you've selected. So if you have something like arm exercise, like on the arm ergometer, you're only activating small muscles of your upper body, whereas if you're doing leg exercise, these are much larger muscles that are capable of doing a lot more work, and they require a lot more oxygen, nutrients, all that stuff. And so your circulatory response is always going to be in proportion to that. Okay. The other thing, and just like we talked about earlier, environmental conditions. Okay, you can be resting, saying you're laying out by the pool on Margarita Day, and your cardiac output will be something like if you went and jogged right now on a temperate day. Okay, so just by laying there and trying to regulate heat, your cardiac output can go to 8, maybe up to like 10 liters per minute, which is fairly light exercise if you're just doing it in a cool environment.
Do you train hard that way?
That's something that's getting more and more interest. Heat therapy, essentially. I was going to do this study. I already had it all worked out. To where you've got to somehow, so I'm gearing this all towards people that don't want to exercise, right? Because that's where all the health problems in America are from, is people that don't want to exercise. I don't need to worry about Hannah. She's going to go play soccer and she'll be fine. It's the people that are like, I don't ever want to get off the couch. So you got to find a way to train them that's not just simply going on a jog, right? So I got to thinking, if all these cardiovascular benefits happen when you increase cardiac output, why not do something that just forces them to be in the heat over and over again? The first thing I thought of was hot yoga. Because people pay money to go do that, right? But somebody published right before I did this study.
That's
So
also exercise, though, too.
yeah, it involves a little bit of exercise, but I think it's more tolerable.
What did they publish?
They published it didn't do much, but I don't think they did it right.
Doing hot yoga?
Yeah, they looked at endothelial function and echocardiography, so it's pretty good. I'm shitting on it, but I shouldn't be. But that was one of the ways, because what if it is just simply putting stress on the cardiovascular system? It has nothing to do with exercise, just stressing the cardiovascular system.
Should just do a sauna.
People do a lot of sauna stuff these days. There's a group in Montreal that's starting to do some sauna stuff. I actually talked to them at the conference.
Wouldn't it take just as much regular body temperature if you're in a cold environment?
It's different. You actually shunt blood flow away from the skin, and so it actually puts less of a demand. It's kind of like laying down.
Is that first or over time?
I don't know about over time. It's just you're basically putting all the central circulation into the central part, so I think it'd actually be almost like detriment. But I don't know. I don't know if anybody's done it. So, yeah, environmental conditions obviously play a huge role in the magnitude of the response for cardiovascular stuff, everything, adaptation, responses, all that. Okay, and emotional influence. So this is really cool, and this is work that came out of UT Southwestern a long time ago. You have something called central command, and it's very, very simple. It's just, if I tell Carmen, here in about 10 seconds, I'm going to need you to jog to Deadman and back. You're automatically going to have an increase in sympathetic nerve activity, increase in cardiac output, stroke volume, and heart rate. Just by anticipating that, oh man, here in 10 seconds, I'm about to go jog. And so it is thought to be kind of like a primer to begin exercise. And I think the way they did it is they literally would just fake people and be like, all right, ready, set, don't exercise. It was a little more sophisticated than that, but you could measure the amount of influence just thinking about exercise has, and the anticipation of moving your legs or whatever causes all these sympathetic and hormonal increases. Okay, and then let me see what else we have today. So this is not a bad place to stop. I want to talk about that actually. All right, 3 more slides. So the transition to rest and exercise and during recovery, I'll just show you on this graph. Okay, so again, you're just resting. Cardiac output's about 5 liters a minute, which is a lot if you think about it. Liters of cola, liter of cola. And you start exercising, you're going to immediately get an increase in stroke volume and an increase in heart rate right off the bat. And so that's going to cause cardiac output to go up, and then it'll plateau depending on the exercise intensity you've selected. And so if this is submaximal, you're going to get a plateau within probably 5 minutes or so. And you'll stay there until you stop exercising. And then it's the same thing with, remember, EPOC and oxygen deficit, stuff like that. Again, those things happen because delivery and extraction. So this cardiac output is going to always mimic oxygen kinetics because it's the delivery of oxygen. And so all those factors that went into recovery from exercise, if you need oxygen still, then cardiac output is going to be the deliverer of oxygen. So it's going to mimic all those responses. So these really shouldn't look that much different than when you guys went over bioenergetics at the very beginning. Okay? And this is the one thing I really wanted to talk about, was rate pressure product. And so this is just talking about incremental exercise, meaning you're doing a VO2 max. And just like you've always done in lab, heart rate is very linearly related to VO2, and it goes up linearly during a VO2 max, right? We all know that. Blood pressure, we already talked about what it does during a VO2 max or graded exercise test. Rate pressure product. This is heart rate times systolic blood pressure. And it's used a lot clinically, actually, because it's really simple to measure. Everybody can figure that out. You can just take a blood pressure and collect heart rate. You guys could have done this the entire semester. But it gives you an idea of the work the heart is having to do. So how much pressure is it having to basically overcome to burst open the aortic valve and eject blood everywhere? And how often is it having to do that? And so this is why people that are hypertensive are very quickly put on either a diuretic or a beta blocker or both. What would a diuretic do?
Increase blood volume.
Decrease blood volume. And so what would that translate to? decreased pressure. Okay, so a diuretic will cover this part. Beta blocker,
Maybe one blocker, just slow down the heart.
right? And so those would be an aggressive form of treatment for somebody that's hypertensive. Because ultimately, just like any muscle or whatever, if you're having to do a lot of work all the time, you're really setting yourself up for injury. And if there's one place that you don't want to have some sort of injury, it's the heart. Maybe the brain, I suppose. So it's really, really simple. It tells you the work of the heart, and it's just heart rate times systolic blood pressure, and it's usually, I've never actually seen it written as double product. I've always seen it written as RPP. And so if you read like a clinical study or something, it might be RPP. Yeah. Okay, so that's all I want to do today. And he may go over this stuff. This stuff's not particularly exciting anymore, because once you get the basics, it's pretty simple. But I'll let him know where we left off. Just a reminder, I've still not had anybody get their protocol approved or scheduled at this point, as of today.
I thought we were approved, we're just not scheduled.
Okay?
Oh, no, we have to send you like all the details. I was gonna do that right after class.
Alright, sounds good. But just know that you guys are running on short amount of time